All right, welcome everyone. Happy Thursday. Happy, I guess, first full day of summer. We are excited to have you here for your workshop called Your NGSS Hour. Before we get into answering NGSS questions and giving you all the awesome resources, let's talk about some norms for the call tonight. If you've been at some of our calls, they are the same as before. Make sure you're muted until you see the microphone icon, or if Hannah or I say like, hey, would anybody like to share? You can use the chat to share ideas you have or ask questions. And then I'm throwing in the chat right now a takeaway document. If we mention any links or resources throughout tonight, it is on that takeaway document. It's a Google Doc, and it's going to force you to make a copy, which means that you can edit it, change it, add to it to your heart's desire after tonight. So let's get into it. First thing, if you missed it just a little bit ago, if you would like, change your Zoom name to your first name, last name, and your state so we can celebrate that we are a nationwide webinar tonight. You can do that by clicking participants, hovering over your name, and there should be an option, a drop-down option for you to rename yourself. As you're doing that, head into the chat, make sure the chat is working, and share why you came to this webinar tonight. I'd love to hear what brought you to us on a Thursday night in June. There's no right or wrong answer. It's just what brought you here. What brought me here is I spend my days in NGSS, and I'm excited that I get to share just a little bit of my knowledge with you, okay? We have some curiosity coming from north of me in New York. What else? In Virginia, we got a notification, was very interested. California inspiration. Cara from California said wants to relight that fire. In Louisiana, learn more info about how to integrate STEM into gardening for my students. That sounds right up our alley. You'll find out why in just a second. Karen, awesome. These are all great ideas. Teach fourth grade science in Pennsylvania and always looking for new ideas. Great. Well, we will get started. Thank you for sharing your whys. Before we get started, I want to introduce you to us. My name is Sarah Nerswick, and my co-host for tonight is Hannah Wedger. Both of us were like life twins, spent 10 years, a decade in agriculture science classrooms from Minnesota, Georgia, North Carolina, and Maryland. And now we get to spend our days living in the three dimensions of NGSS as learning designers, and we specialize in unit development. All right, here is what we're doing today. This hour is going to be spent learning and asking. We've spent some time, this is our fourth webinar on an 8-webinar series, and we've been getting a lot of questions and common questions from teachers who've attended the workshop, and we're going to dive deeper into those questions. We're also going to let you walk away with a few routines that you'd be able to use in your classroom right when you step back in when school begins in August. Picture this, I can see you now. It is a hot August afternoon. You just said bye to your last student and said, see you tomorrow. You head back to your desk, you take a deep breath and realize, wow, today went really well. The kids took charge of their learning. It was almost like you were a fly on the wall, observing them learning, collaborating, and investigating. And you are happy that you spent some of your summer learning about NGSS and honing your skills as an educator. And you just can't wait for the next day to try more. And that is what you'd love to see in your classroom in August, right? Well, that is why we're here today. And Hannah is going to start us off sharing the first technique, the question formulation technique. So take it away, Hannah.
Like Sarah said, our goal for you is that you walk out of here today, or you walk away from your home office, or get off the couch with new tools in your teacher tool belt to use in the classroom. Maybe not tomorrow, because I'm hoping most of you are on summer break, but when you go back into the classroom this fall. And I'm excited to share the question formulation technique with you tonight. The question formulation technique, or QFT for short, is a simple, rigorous step-by-step process to help students produce, improve, and strategize on how to use their own questions they develop. The technique allows students to take their questions to a deeper level, and your job as the teacher is to facilitate students through the question formulation technique steps. Okay, so I thought, what better way for you to learn that facilitation technique than by running through the steps as if you were a student yourself, so you can get the feel for what it's like. Okay, so you're going to need two things. You're going to need a pen and a piece of paper. Okay, a pen and a piece of paper, and we're going to get into it. So let's start by focusing on the topic of exploring ecosystems and biodiversity by looking at a specific phenomena. So this is really cool. I have a GIF here on the screen, and tonight you are going to get started with QFT. Like I said, you're going to take a moment to brainstorm questions on that piece of paper and that pen that you just grabbed. Okay, so I want you to look at the GIF and just write down as many questions as you can on that sheet of paper. I'm going to give you 1 minute to do so, and then we are going to share some of those in the chat. What questions do y'all have? Giving you that good wait time. All right, I'm going to start my timer now. You have 1 minute to write down as many questions as you can. If you don't have a pen or paper, do it on your phone in the notes section, or open up a text message and fill it in there. On your mark, get set, go. As many questions as you can think of in 1 minute as you look at this GIF. About 10 seconds. So write down your last question that comes to mind. Okay, that was 1 minute. Hopefully you got a handful of questions written down. What I want you to do is share some of the questions that you came up with in the chat. Don't think about what questions you share. Just grab 3 or 4 from your list and drop them into the chat. What is the river changing? Herd migration as seen from Google Earth. What are the dots surrounding the blue? Which river is this? What other questions did you have? Will it ever return to its original formation? What is the legend? What is the rate of flow? Where is it located? Why does the path change? Is the blue line a river? What satellite is this from? What year did the river have the highest water levels? Ooh, Sarah, they're on fire tonight. This is good. Great job, everyone. Okay, so there's some really interesting and thought-provoking questions in the chat that y'all came up with, and you're really off to a good start. So in a QFT, there are 4 rules. So when we think about question formulation technique for our students, there's 4 rules to question formulation. They are: you want your students to ask as many questions as they can. Think of it kind of like a brain dump of questions. Second, you want to tell your students, hey, don't stop to discuss or judge or answer any of the questions, just get them out. Okay, so just keep them rolling. 3, write down questions exactly as they come to mind, numbering each one. So it doesn't matter, like you don't want students to think about like, does that sound stupid if I have that question written that way, or I don't quite think it gets to what I'm trying to ask. We're not doing that. We're just writing them down. We're not judging them at all. And the 4th thing is we're going to change any statements that students come up with into questions. So if a student has a statement, you just ask them, hey, change that into a question. And students might need a little bit of help with that, but those are our 4 rules. So ask as many questions as you can. Don't stop, just keep going. Write down the questions exactly as they come to mind and change statements into questions. So we're going to do this one more time. And I'm going to show you the same exact GIF. I'm going to give you 1 minute again. And what I want you to do is try this out using the 4 rules that I just gave you for the question formulation technique. So try it again. If you want to just type them right in the chat, go ahead and just type them. Just don't hit enter until the end so people don't see your questions and get them or get ideas from you. Okay, so go ahead. You have 1 minute. Use the question formulation 4 rules. Go ahead. As many questions as you can think of. Don't stop. Write them all down. If you have any statements, change them to questions. You're doing good. Keep going. You have 15 more seconds. Keep jotting those questions down as fast as you can. Don't judge them. Write them exactly as they come to mind. Any statements, change them to questions. All right. 3, 2, 1. Okay, that probably felt a little bit different, right? That probably was like, oh, now what I want you to do is I want you to take a moment, look through the questions that you typed out or look through the questions that you wrote down on your sheet of paper and select the one question from your list that you found most interesting. Okay, and you can go ahead and just put that one question in the chat, single it out, put it in there. I'll give you a second to find the most interesting question from your list. Okay, does the depth change as time goes on? How is 1988 different than 2008? How have changes to the river changed river use? Oh, great. What contributed to the changes we see? How did they image the river? Great. These are great. Okay, this is what you're going to have your students do. This is exactly what you're going to have your students do. What made these changes occur over time? Good. So in a normal classroom setting, I would take you through the next steps of QFT, but for time's sake tonight, we're only here for an hour. I'm going to share what would happen next in the classroom and how you would facilitate QFT just a little bit further. So next, students would have their big, long, huge list of questions, and students are going to take some time to improve their questions by doing a couple of things. One, they are going to categorize their questions and discuss the value of each type of question presented. Now, depending on what they're looking at, they might categorize those questions differently, and that's okay. It's up to them on how they want to categorize them and how they want to value them. This could also be done as like a classroom activity, okay? Second, they are going to change close-ended questions like yes or no answers to questions to open-ended questions, okay? And they don't necessarily have to cross out the closed-ended questions, just right near those closed-ended questions, they can write the open-ended questions. And then vice versa, for any questions that are open-ended, they're going to change them to closed-ended questions or write another question that is just that question as a closed-ended one. So what that does is that just develops their list further, and so that they have this really robust list of questions. Next, they're going to look at that robust list and they will choose 3 questions, similarly to what you did, choosing the most interesting question, and 3 questions that have one of these or multiple of these qualities. So questions that are maybe the most important to solve, that will help you research or will help the students with research, that they can be used in an experiment or used to help develop an experiment, used to guide reading and writing practices or experiences. They can choose a question that can be answered through discovery, or choosing a question that will help them solve the problem. So they'll choose 3 of them, and then teachers would discuss next steps on how they would utilize those questions. So maybe they're going to use those questions to develop a lab or develop a model or create a poster, or to guide some research. So really, as a teacher, it's up to you to determine how you want your students to use them and guide them. So that is really quick, down and dirty, the QFT activity. Remember, this is just one tool that you can use to help generate a lot of questions and refine some of those open-ended questions related to scientific inquiry. To help you facilitate this in your classroom, I want you to be successful and be able to implement this tonight or tomorrow if you needed to. So in the takeaway document, there are QFT steps and helpful tips and resources for you so that you can feel ready to use this in your class this fall or even this summer. So remember to keep exploring and asking those questions.
Awesome. Thanks for sharing, Hannah, that new technique that we can use in our classroom. Before we move on to our next routine, I'm just going to give us a second that if you have a clarifying question that you want to ask Hannah about QFTs, to throw it in the chat, or here's another fun feature that you have. If you go to reactions at the bottom of your toolbar, there is a raise hand function, and you can raise your hand and we can call on you. Is anyone else having issues with the takeaway document? Let's see. Oops. Hold on. That's a great question. Oh, we have some no's. Yep, it's working on my end. If it happens, we can, oh, you were recently hacked. Sorry about that. It happens with school stuff, right? Okay, if we don't have any other questions about QFT, I'll ask Hannah, when's a good time to use this? Is this something that should be used at the beginning, like in phenomena? Is this something that can be used in the instructional sequences? Like, where would you suggest using a QFT routine?
That's a great question, Sarah. I think we have a lot of experts here. Y'all seem like you're really comfortable with this. So feel free to answer in the chat if you have a place or time when you really lean into QFT. I think when we think about NGSS, this is a great way to help students develop questions for a driving question board, and get curious about the phenomena or the problem. So I really see it being like the beginning of a unit or the beginning of a lesson. But I also think it's a really great technique to use if you feel your students getting stuck, if you feel your students like kind of pitter-pattering out, or if they're just like kind of losing some interest in the topic or the subject. This can be a great way to bring up questions that they have that maybe are unanswered and that would drive student motivation.
Awesome. Thanks for sharing, Hannah. I know one time we used this when we had a anchor phenomena, and we were trying to figure out, well, what questions would students ask as we're building out what modules they're going to go through. And that was very helpful, even for adults, to like put on your student hat and start thinking like a kid, like what are they actually thinking? All right. Yes, we will try and get the PDF to you guys in just a second while we're going through the lesson screening tool, which is our next routine. If you guys have ever thought like, hey, I found some NGSS units or lessons online, and you just want to make sure that they're quality. I get it. I want to make sure like what I'm using is actually doing what I want it to do. It's important to evaluate those materials you find online to see if they stand up to your high standards and also NGSS high standards. And you can use a tool like the lesson screening tool. It allows you to like screen for all those important facets of NGSS. And today you are going to have a second to evaluate a transfer task that we have access to see if it holds up to the high standards of NGSS. So in that takeaway document, there is a transfer task. And if you don't know what a transfer task is, we talked about it a little bit at one of our last webinars, and you guys can, I think tonight, check out the loaded versions of those awesome webinars, and we talk in depth about transfer tasks. A transfer task is a summative assessment in which students must transfer the learning gained in like the unit into a new situation based on similar 3 dimensions. So if we go, we're going to talk about a transfer task about grazing cattle, and that again is on your takeaway document. Go ahead and take a second to open up that transfer task. I think it's maybe the 6th line down, called grazing transfer task. What you're going to do is look at this lesson screening tool. This has 12 areas where you're answering the question, yes, partially, or no. For example, the first question is, this lesson contains a phenomena or a problem. Yes, no, or partially. And as you're going through this, obviously, if you get more no's, it's probably not a good fit for what you want. If you get more yeses, it probably is a good fit. So we're going to set a timer for about 4 minutes for you to go through this transfer task. And I want you to focus on questions 1 through 5. 1's about phenomena, 2's about student-centered learning, and then 3, 4, and 5 are about the 3 dimensions of NGSS. So look at the transfer task and then look at these lesson tools. We'll bring up the next slide or we can leave it at this slide. Any questions? You're going to open up that grazing transfer task, scroll around and see if you can find evidence of those quality NGSS things in there. All right. Timer is going. You have 4 minutes. If you have any questions, feel free to write them in the chat and I will answer them as you go through the lesson screening tool. The lesson screening tool is also in your takeaway document. If this is too small for you to see, we also uploaded it for you. You have about 2 more minutes before we're going to chat about our answers. All right, take the last couple seconds to figure out. I know it's very quick. You would have a lot more time to do that if you're actually reviewing for your class. And again, we're just focusing on questions 1 through 5. Okay, here is how we're going to share our thoughts. In just a moment, a poll is going to pop up on your screen. It's going to give you the opportunity to answer questions 1, 2, 3, 4, and 5 based on the evidence that you found. Again, just throw an answer in there. If you can't 100% confirm it, write partially. If you can't confirm it all, write no. It's okay. We'll go through those and see what you guys thought. So Hannah, you can let the poll go and just vote for 1 through 5 if you saw it. And the questions are on the poll. Can everyone see the poll? Do you see it on your side? Yes. All right. We're seeing answers come in. Perfect. Give you about 30 more seconds to get those answers in there. Thank you for those of you who are participating. So 10 more seconds. All right, Hannah, if you want to end that poll, we can look at our collective answers for this one. So you guys should be seeing the same answers I have. The lesson contained a phenomena. Everyone answered yes. Yes, it is very easy to see that there was a phenomena on here. I think it was page 6 is all about phenomena. The lesson is centered around student-centered and kids need to figure something out. Now, I don't know this transfer task really great. I did see evidence of students looking at things and they had to explain. I might need to dive deeper to like confirm that this is student-centered and we're not dictating the way the students need to do everything. In NGSS, choice is important, student voice is important, and they need to make sure they're figuring something out and we're not giving them too many answers. So I might need to dive a little bit deeper, but I would agree with most of you who said yes or partially. The understanding of DCIs, number 3, is assessed. We have yeses and partially. I would agree. When you're looking at DCIs, CCCs, and SCPs, it's important to make sure you're looking at the DCI matrix or the progressions to make sure this is a task for 5th grade earth science. So we want to also make sure that the DCIs are not too high level, that they're hitting at the middle school level, or too low level, that they're in the K2 area. So you might need to take an extra minute to look at those and make sure they're not going too high or too low. So I would agree with you. The SEPs, we agreed, yes, and partially for SEPs. What are they doing? They're doing a lot of modeling in here, lots of drawing, and I saw evidence of it in here, and I would agree, yes. And then cross-cutting concepts aid in sense making. We said cause and effect and system models. We had a couple yeses and a no. In here, I do see cause and effect come up, and then they're using models in both SEPs and CCCs. So we might just need to take a little bit more investigating, but I agree that we just need a little bit more time to see it. But you can already tell that the people who participated, you can start to see what are those things and how do I need to evaluate this type of material if it comes to me. And I want to remind you that the 3 dimensions are not the only things that you need to know about for NGSS. Yes, they're talked about a lot. There is also student discourse, relevancy, age appropriateness, differentiation that's important. So when you're screening a lesson, make sure that you use all 12 aspects of the lesson screening tool. Okay, we agree. We Scouts honor that we'll do that next time that we screen a lesson. You'll find all this information, so you'll be able to use it the next time you come across a lesson.
All right, Sarah, thanks so much for sharing that and just letting us kind of play around with, hey, does this transfer task, is this going to work for in my classroom? Is it 3 dimensions, all of that great stuff. So I want to take a moment again to just pause. And if anyone has any questions, to give you that space to ask questions. So you can either put your question in the chat sorry, I was reading the question already. That one came so fast. Or if you have a question, you can also use the feature of raising your hand. But it looks like Megan is ready to go. So middle school lessons, where can Megan find some?
That is a great question. Now, you guys are the teachers in the classroom. So if you have a resource that you have found really reliable lessons, throw it in the chat for Megan, and I will share the last link on your takeaway document. Has the link to the Food and Ag Center for Science Education. Okay, on there are tasks, there are full units, there are toolkits related to NGSS that are free and available. Like, go ahead and go for it. Lower grades. There are some lower grade materials on the center, and I know that there's being more built for lower grades. So hopefully, cross your fingers. Another way, we've used that grazing task before, and we've just changed some of the prompts to fit a lower grade band. So again, it's kind of like doing the lesson screener. Oh, this is the SEP they're doing. We need to move it down. How could we tweak that prompt if we really like this activity to fit for our students? And good news, because these are Google Documents, you can download a copy and edit it to your liking for your students. So awesome question, Megan and Gina. Thank you for that. And Mandy just put another great source into the chat. And Karen had a question about where are the 12 questions to review. That's going to be on your takeaway document. I will drop it in the chat one more time. And it should be, what number is it? The Lesson Starter Graphic Organizer is what it's called on there, but it should look familiar. All right, Hannah, are there vertically aligned lessons that span grade bands? Carrie, on the center, Hannah might be able to better answer that. I'm not sure.
Not at this time, no. Mm-mm. It is something that I believe that they're working on to develop, but not at this time.
Yeah, a big holistic, everybody can come. They're working on it.
Yeah.
Good. All right.
That question before, Carrie, and so it's been something that we've started to put into the works of developing. Okay, so we're going to wrap up our resources portion of the schedule tonight, and we're going to dive a little bit into inquiry here. And so what I want you to do is before we get into inquiry, I just want you in the chat to write down what comes to mind when I say inquiry. Like, real quick, what is that? What comes to mind? What are the few words that you think of when I say inquiry? Curiosity. Great, Mandy. Sustained inquiry. Ooh, I like that. Questioning. Good. Allowing students to explore without giving answers. Investigation. Student directed. Yes. Student discoveries. Wonder. These teachers are so great tonight. Y'all are filling my cup. Okay, thank you so much for sharing. So y'all are on the right track. This was exactly the things that were coming to mind when I think of inquiry. So you will find inquiry all throughout NGSS instruction. And the purpose is to get students to care about what they're learning, to engage in the content and with one another. And one way to do that is to get them asking questions. So similar to the question formulation technique you learned from me earlier, the goal is to get students to become really curious. And this is easily demonstrated in the opening of NGSS instruction with a phenomena or a problem. So we're going to try it out tonight. And what I want you to do is on a piece of paper, can be the same piece of paper that you wrote a bunch of questions on for me earlier, backside or wherever. I just want you to create a T-chart like the one on the screen. And Sarah is going to play a clip for me in just a second here. And it's just going to be a few, is like a snippet of a video. And then I'm going to give you 1 minute to write everything that you noticed from that video and you wonder from that video. And then we're going to watch a little bit more and you're going to keep going. Okay, so hang with me. Sarah's going to quick take over the screen here and you get to see a quick few.
All right, can you see it, Hannah?
Yep.
All right, you get 3 seconds.
Okay, so you have 1 minute. I want you to go ahead and write down everything that you can on your notice and wonder T-chart. Go ahead. $30, keep going. Things that you noticed. Maybe you noticed a little hairs. Things that you wonder. You wonder what the heck this is. All right, 5, 4, 3, 2, 1. Okay, stop writing. Sarah's going to give you another few seconds of this clip.
There we go.
Okay, so you're stopped now. I'm going to give you 1 more minute. Go ahead and write down or add more to your notice and wonder chart. What else did you notice? Things that you were seeing on the screen. What did you wonder? What questions started to come up for you? Got about 20 seconds. Great, go ahead and write down your last thoughts here. Okay, Sarah, give us this last part. Okay, you have 1 more minute. You've seen the full part of the clip that we wanted you to see. So go ahead and write down, now that you got to see what the full thing was, what are you going to add to your notice and wonder chart? You have 1 minute. Go ahead. All right, take about 10 seconds more. Okay, so what I want you to do is I want you to take one question from your wondering column and go ahead and share it in the chat. One question from your wonder column and share it in the chat. This video is a fun one. Is it edible? I wonder why it's dirty. Is it food? Is it a black line dirt? What was the temperature of the object? Oh, Ross, let's go. That's a great question. Is that a body part? Is that a line of dirt? Okay, so you're like, what the heck is this? Good. So what this does is we're using inquiry, right? And with inquiry, we know that there are still unanswered questions, even after we found out that we're looking at a mushroom. So after you found out that you were looking at a mushroom, some of these questions you still are not quite, we don't have a positive yes or no answer. Some of them we do, but some of them we don't. Is it edible? I don't know. What kind of mushroom is it? We're not sure. So we use this inquiry to start to get students to build questions or develop questions similar to question formulation technique. It's just a different way. So when students are presented with a new stimulus like phenomena or problem, you might want to prompt them with some of the questions on the board to help them get curious, to help them start to inquire about what's going on. So what do I notice? What's the problem? How can it be tested? What changes or what stays the same? What's the function? And these are all things that your students can ask, or you can prompt them to answer. So we've added materials from The Wonder of Science, which if you haven't visited is a great site, to your takeaway document so that you can start to dig into inquiry a little bit more, and it can help your students. It's just another way to help your students ask better questions.
Awesome. Thanks, Hannah, for sharing that last resource with us before we get into those top questions we've gotten at our past webinars. Does anybody have a question about the activity you just did? If you're interested in that, yes, we love The Wonder of Science here too. That website, I'll try and find it and get it in the chat. There's some really cool images. I think there's a tomato on there. I don't know. But it's mesmerizing. I couldn't stop watching it once we found it. So any questions for Hannah? If not, I'm gonna ask her one before we move on to those 3 top questions. All right, Hannah, do you see this showing up in more than just an investigative phenomena or an anchor phenomena?
Ooh, that's a great question. I think so. And I think when we think about, again, y'all are teachers and are in the classroom every day. So if you're using inquiry in other places, let me know. But I think this is, again, like I said, with the question formulation technique, another way to kind of get students thinking, get them curious, helping them to dig into content a little bit deeper. I envision, like, let's say students need to create a model and you see that students are just getting stuck. This inquiry piece can be really helpful in maybe helping them understand a certain part of the model, or to get curious about maybe gaps that they have in their model. And that's just one example. So think about, like, when's a time when I need students to start asking good questions? When is a time that I see my students getting stuck? Typically that they need some help to get through, or they need a jump start in their creative engine. So
awesome. Thanks for sharing. All right. Well, we are going to get into the last little portion of tonight. We've hosted, like I said, this is our 4th webinar, and we have a survey at the end, which you guys get an opportunity to write questions and give us feedback on the webinar. And we've seen these questions pop up time and time again, and we said it is time to address them. So I'm going to go over question number 1, and maybe you've been thinking this question too. Question number 1 is, how do I choose DCIs, CCCs, and SEPs? The best thing about this question is, I know that you're taking action and you're going out there after going to a webinar like this and you're trying to figure things out. And the good news is the answer is closer than you think. And I've cut it up into 3 steps. So step 1 of this question is you got to start with the phenomena. Before you even think about DCIs, CCCs, and cross-cutting concepts, you have to start with a phenomena because that is what drives student instruction. Remember, a phenomena is an observable event that can be explained through science. And here is an example from NGSS phenomena. That is a wonderful resource. I'm using it in a couple of these examples by Dr. TJ McKenna. Amazing phenomena are on there if you want to get started. And if you put this picture in front of your students, I can almost hear my high schooler say, wait, a strawberry starts as a flower? Oh, what the heck? I didn't know that. And that is great news. When your kids are asking questions like that or having outbursts like that, that means you picked a phenomena that helps your students enter sense making. And the first step of sense making is curiosity. The next step of how do I choose DCIs, CCCs, and SEPs is to think about these 3 questions. And I need you to do rapid fire in the chat for these questions. Okay, rapid fire. We don't got time to lose. We need to get to business. So when we're looking at this phenomena, I want you to think, what would your students do as they interact with this phenomena? What actions would they be taking to help make sense of this? Literally any answer is great. Just throw it in there. Eat the strawberry, I didn't think of that. Look for seeds. What else could they do to make sense of it, to look at it and then be like, okay, how do I explain this in a different way? They'll ask some questions. Maybe they'll compare, draw a picture and label a picture. Amazing. Yeah. What kind of actions, what kind of activities will they be doing? Like Megan mentioned, drawing a picture, labeling a picture. Analyzing data. Awesome. So some things that they might be doing, like drawing a picture, they might look at, you might even have time to do an experiment and grow strawberries and see how long all the times are. Okay. Count the seeds in each phase. They might need to write an explanation of the growth cycle, look at it and write an explanation, explain what's happening. And what you guys just came up with are the SEPs for this lesson. You just started picking SEPs. SEPs are what students do, okay? Creating models, analyzing data, engaging in arguments, obtaining information, okay? You just picked an SEP. So next, what do students already know to connect with this phenomena? Have they ever seen anything like this before? Can you think of anything that's similar to this in the science world that they might be like, oh, this is kind of like this, looking at changes of growth, comparing growth cycles of strawberries with another plant, okay, comparing and contrasting, cause and effect I see in there, animal life cycles, how a baby grows, absolutely. So what you guys are coming up with are those cross-cutting concepts. Cross-cutting concepts are how they make sense. Like, how do they connect that to other areas of the world? Like you said, plants, animals, people, okay, growth time, growth length. Those cross-cutting concepts like structure and function, like that would be great for this. Structure and function, like what are the structures? What are the functions that are happening? Why does it need to change? Okay. You might figure out that what is the cause and effect? What causes it to go from this part to the next part? Okay, so you figured out your cross-cutting concepts. And the last one is, what do students learn after interacting with this phenomena? What knowledge are they going to walk away with? What are they learning? If you made it science-y, what are they learning after looking at this life cycle? Tell me in the chat. What are they walking away with? Life cycles are everywhere, absolutely. Living things change over time. Thanks, Mandy. Very good. Pollination, yes, 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 all of those. What students learn after interacting with a phenomena like organisms reproducing, they're figuring out maybe they have specialized cells. Maybe plants, how do plants end up growing and changing? Like, how does that happen? What plants need light to grow? Like, does a strawberry need light to make that whole cycle happen? Those are your disciplinary core ideas. Okay, those are the things that the science that they're learning through the cross-cutting concepts and the SCPs. And you just did it. You just created, all of you just created DCIs, SCPs, and CCCs for this phenomena. And they align really well with life science DCIs, this particular one, because it's a life science. So step 3, I just want you to remember that there's no right answer when you choose your DCIs, SCPs, and CCCs. If you are focusing on your kids in your seats and you're focusing on their grade level, DCIs, SCPs, and CCCs, and you can make it work and they can progress and become proficient in those 3 dimensions of NGSS, there's not a wrong answer, okay? You could go the specialized cells, you could go the model way, you could go the cause and effect way, you could go to the structure and function way. That's fine. Choose it, stick with it, own it, and then make sure students are progressing and becoming proficient in those elements that you choose. All right, that's question number 1. We did it. You guys just answered question number 1 and did it as an example. Hannah, what about question number 2?
All right, the next most frequently asked question actually aligns really well with what Sarah just discussed, and it's like the next step. So what do I do next once I've picked a phenomena and I've figured out my 3Ds, the 3 dimensions that I'm going to use? How do I go about making a lesson? So I'm going to show you a tool on how you can do that. So up in the corner here, you will see the top right-hand corner, you'll see what we use and what it's called a lesson outline. And so this is really a way for you to develop a lesson, get all your thoughts out on a paper, so then you can start putting it all together. So let's go through this quickly together. This is also in your takeaway document as a PDF, so you can print it out and write in it, or honestly, I just take a notebook piece of paper and write out my phenomena on each of the different parts. So let's take the strawberry phenomena. That's what we're going to write in our phenomena area there. The next thing that we're going to take a look at is the stimuli. Now, the stimuli is, I want you to think about, like, how will your students experience the phenomena? So for the strawberry phenomena, we have the picture. That's the stimuli. It might be something different, like a video or a data set. It really depends on what your phenomena is and how your students can start to get curious about it. So you want that stimuli to get them interested. You want it to make them lean in a little bit and go, wait, what? I have questions still. The next part of this outline is student products. Now, this is where we go to the end of the lesson and think about, what do I want students to create? What is my student artifact? Are they creating a model? Is it a poster? Are they making an argument or developing an argument? How am I going to assess them? So think about your phenomena and your stimuli, and then go to the end and figure out, what is that end game that I want students to create? What is that end product? And that is what you're going to put in the student products portion. The next thing, if you slide across to the right, is the notes about relevance and authenticity. Now, when you think about relevancy and authenticity, I want you to think about, how will you engage your students in your classroom and their funds of knowledge? How will you engage your students and their interests? And how will you engage your students and their identities? And I want you to think about it in terms of the phenomena that you're presenting and the stimuli that you're showing them, and how does that how can you make a relevant and authentic learning experience when you think about their funds of knowledge, their interests, and their identities? Now, if you go to the bottom left-hand corner, this is student questions. You're good at asking questions. We've already proved that tonight with the question formulation technique and inquiry. So use one of those techniques with yourself, right? And write down as many questions as you think your students will ask when they're presented with that stimuli and that phenomena. And even when you think about that final student product that they are going to create, what are all the questions that they're going to need to ask to get to that point? And this really is your driving question board for the lesson. So it can guide the student learning. It can motivate them through the lesson because they want to answer these questions. Now, in that last box in the bottom right-hand corner, these are considerations. So in the other portion, these are things that I want you to think about when creating a lesson. How will you provide scaffolding for your students? So thinking about that end product that you want them to create, that end artifact, what do you need to provide them? What supports do you need to provide them so that they can get to that end product successfully? What previous knowledge are you assuming that students have coming into this lesson? And then how will you modify and or support for students with IEPs or students who are multi-language learners? So that is really quick, down and dirty. I also know that some people use this to develop an outline for a unit as well. So it is, you can use it for whatever works for you, but this is a really quick, easy way to get thoughts down. And then you can start creating student worksheets and things like that that you'll need to use once you have all these ideas.
All right, and last question we got is, I'm having a hard time writing phenomena to go from a question to a statement. How can I shorten it? So I'm going to walk through an example that I created for y'all. So here is a picture. It is a picture of whales bubble feeding. How cool. So what I would do is, how would I turn this into a question? Number one, it's a theme of tonight. Write down as many questions as I can. Okay. And then, so it would be like, why are there so many birds? Are they working together? Why do they work together? How do the whales not hurt each other when they're like that close and that big? What are they eating? Why are there so many bubbles? And I will just switch those to statements. For example, whales work together to feed. Whales create bubbles when feeding. You did it. You turned a question into a statement. But here is the important part. When you're looking at a phenomenon, you need to make sure that it goes by the checklist, the phenomena checklist, to make sure it's a good, viable phenomena. So let's go through this one. We're just going to do this example because we need to wrap up. So I've selected elementary DCIs and high school DCIs that I think fit this phenomena. And I'm going to go through really quick these 5 questions of the NGSS evaluating phenomena checklist from the National Science Teachers Association. Okay, you should be able to see those on the screen. So here we go. Number 1, does the phenomena address the DCI target? And you would answer all, partially, or none, kind of like your lesson screening tool that you used earlier today. So I would say all for elementary. Being part of a group helps animals obtain food, defend themselves, and cope with changes. Maybe I would cross out those last 2 things, but definitely helps animals obtain food. For high school, I might only say part, because the end part of that DCI is about genetic relatives. We might not get there if I use this. We could get there, but I'm just going to say maybe not. Question 2, is the phenomena observable? Yes, it is. If you went to the NGSS website, this is a GIF. And the whales are coming out. You can find a YouTube video, okay? It's observable. Is the phenomena likely comprehensible to students? Yes. Basically, that means, does it fit with the DCI? Okay, is it easy to comprehend? Yes, it's easy to comprehend. There's bubbles, there's food, there's whales, something is happening, they're working together, let's figure it out. Number 4, is the phenomena suitably attention-getting, relevant, thought-provoking, and requires an explanation? Yes, if I saw this in real life, I'd be like, what is happening? This is so cool. And I want to point out that phenomena should not be easily answered by a quick Google search. And this one, you might think it could be. And it depends on how you write the unit, write the lesson. If you just say, why do they, like whales bubble feed? you can probably find the answer. But if we're diving deeper into those DCIs, like how is that working? What is the physics of the bubbles? Why do fish get trapped in the bubbles? How do they not get hurt? How do they work together? How do they communicate to get there? There's so much more to this one question. So make sure you pay attention to that when you're doing phenomena. And last, question number 5 is the use of phenomena is efficient in the benefits. It justifies financial cost and the time devoted to the phenomena. Yes, there should be little to no cost of you using this phenomena in your classroom unless you want to travel to Sitka, Alaska, where that's the best place in the world to see this happening. So far, I think this is a great phenomena, and make sure that you're using that checklist. I'm going to drop it in the chat. It didn't make it to the takeaway document. That phenomena checklist is really great to use. You're muted, Hannah.
Of course I am. Goodness. I said it's been a great night, and we spent the last hour diving into learning so that you can implement NGSS resources in your classroom with ease. We appreciate all of your willingness to share and work collaboratively with your fellow educators and jump in the chat and sharing links. All of that is so great. And so to wrap up tonight, we have 2 quick tasks for you. First up, we would love for you to spend 1 more minute with us in the chat and just share one of your biggest takeaways from tonight. And then the other thing that we would love for you to do is take a short survey before you leave so that we can make our next NGSS webinar even better. That's also how you get your continuing education units or credits for attending tonight. So everyone that fills out the survey, we will share your certificate after you have completed that survey. Speaking of this webinar, in our webinar series, there is another webinar coming up on July 13th at 7 p.m. Eastern Standard Time. Sarah and I will be there along with one of our other facilitators, and that workshop is called Students Asked, and we answered Agriculture Phenomena Part 1. So we had actual students that came in and said, hey, we have these questions about agricultural things, and we have some experts that are coming in to help answer those questions. So it's one that you're not going to want to miss. Today's learning experience was funded by Beef Farmers and Ranchers. We thank them for their continued support. And again, we just want to make sure that you take that survey so you can get your CEUs, and that we can prepare and be better for our next NGSS webinar in this webinar series. We can't wait to see you in July. Have a good night, everyone.
Yeah, thanks for being here.
Thanks so much. We'll stay on for just a second longer if anyone has questions. We're glad you're excited about the handouts. That's one of our big goals, is to make sure you have stuff that you can use, and not just a notebook full of notes, but actual things that you can use. Katie, I'm glad you liked the screening checklist and the examples and resources. That screening tool is really nice. Yes, Cara, I'll email you the takeaway link. Hopefully we can get it working that way. We're not able to share PDFs for some reason through Zoom, so I'll share it, or I'll email it to you so you have it. Great. All right, everyone, well, have a great night, and we will see you in July.